Hi, today we're going to be talking about section 2.3, rate of change and slope. We're specifically going to talk about the constant, what a constant rate of change looks like, what average rates of change look like, how to find a slope using coordinate values, and how to find a slope using a graph. So a rate of change is just a ratio that compares how much one quantity changes on average relative to how another quantity changes. For example, a lot of times we'll talk about how our cars get travel, and that's a miles per hour. The velocity a car travels is miles per hour. That's a rate of change. How quickly is position changing in terms of time? So position versus time there. Here's an example that shows a pool being filled. And as I look at this, I see a typo. So pretend that where it says number up gallons, that should say just of, not up. So sorry for the typing error there. But number of gallons. Okay, so if we look at how the water is changing per time, or gallons per minute is specifically what the units are in this. You can see the graph here, and 2 points are given specifically. It says 3 is our x value because it's the first one, because all coordinate values are given with an x, comma, and then a y value. So our x value, our independent variable, is 3, and that's relating to time here. So that's at 3 minutes, there are 108 gallons, because gallons is the dependent variable. The gallons depends on the time. So if we look at that, that's one of our coordinate values. We want to see how the number of gallons change in terms of how time is changing. So they also give us the second value, that's 7. At 7 minutes, there's 252 gallons. So if we look at this, a rate of change a lot of times is just going to be represented by the change in your y values, or the dependent variable, divided by the change in your x variables. And instead of writing that out every time, mathematicians write change as a delta. So that looks like a triangle. It's a Greek letter delta. Delta y over delta x just means change in y over change in x. Okay, so if we just take a look at this from the y values, from 108 up to 252, anytime you're trying to find a change in something, you just subtract it. It's the difference between the two. So 252 minus 108, so that would be 252 minus 108. Okay, that part of it is equal to, let's see, 144. Okay, and then if we look at the change in our x values, okay, from 3 up to 7, that's a lot easier, but we'll write it again as, for finding the change, it's the difference between the two. So 7 minus 3 is 4. Okay, so 144 divided by 4. Well, 14 divided by 4 is, we can do that with 12. So that'd be, 4 goes into 12 3 times, but we didn't use 2 of those numbers, so that would carry on to the next number. So 24. 4 goes into 24 6 times, so 144 divided by 4 is 36. Or just use your calculator. That's much simpler. Okay, so we have a rate of change that is 36, but we need to talk about what 36 means. That means, again, we need to look at the units. This was delta y, that was the gallons. Gallons per, meaning divided by, minutes. We found that by dividing the change in gallons divided by the change in minutes. So this pool is filling up at a rate of change of 36 gallons per minute, meaning every minute there's 36 new gallons that go into the pool. Okay, this is a constant rate of change. This is not realistic. If someone went and flushed the toilet, all of a sudden that rate is not going to be 36 gallons per minute anymore. It's going to go down. So this is not real life. Most of the time, typically, we're going to have to look at what is an average rate of change. It's treated the exact same way. We just have to look at the the starting value and the ending value. But most of the time, it's going to go up and down every minute or every year or whatever your X values are in terms of. It's not going to stay constant. So if we were looking at a graph, you could have a graph where it's going like this, but we have some average rate of change that covers that whole distance. Okay. So let's specifically look at this example. In 2002, 23,142 students applied to State University, and 34,689 students applied to Central University. In 2010, 29,563 students applied at State College, and 36,107 applied to Central. Determine the average rate of change in applicants for State College. So we just need to look at the State College numbers specifically. So State College are those numbers and these numbers. Okay, so if we just think again, rate of change, even if it's average rate of change, it's just how did the Y values change? How does that second, which would be the number of students who have applied, change compared to the number of years? Okay, so if we just do 29,563 minus 23,142 over, the years are 2010 minus 2002. We know that's 8. That's 8 years. This is over an 8-year period, so that's a nice number. If we subtract the two numbers of students, we're going to get a difference there of 6,421. Okay, if you pop that into your calculator, divide 6,421 by 8, you get 802. Let's think about the units. We took the number of students divided by the number of years. So maybe we'll say 0.6. Students, I'll just abbreviate that studs because you guys are all studs, per year. So that's 802.6 students per year. So the average rate of change for this college, how it's changing, every year there's 806 more students, because it's a positive number. There's 802.6 more students per year. That's the average rate of change there. Okay, go ahead and hit pause and find out what the rate of change for Central University is. Go. Alright, if we were to look at Central University, we're going to be looking at these numbers. The years will stay the same, so it's still 2002 and 2010 for our X values. Man. But now, since it's Central University, we're going to be using this 34,000, and it actually goes down to 29,000, or no, I'm sorry. You're going to be using the 36,107. So it still goes up, so you should get a positive slope here. Let's just go ahead and hit pause and use those numbers to figure it out again. Use the 34,000 and the 36,000 numbers for Central University. Go. Okay, hopefully you got, it was 36. We're just taking the difference between the two. 36,107 minus 34,689. Notice how we're always taking the second number minus the first number. And then it's the 2010 minus the 2002. Okay, if you do that, you get 1,418 over, again, 8, because it's over an 8-period time. So if we just look at the 2 without even typing this into the calculator, we know this is going to be a smaller slope because we've got a smaller number in the numerator. State College had 6,000. This one has 1,000, or I guess it was 6,400 compared to 1,400. So let's pop that in the calculator. Divided by 8, we get 177.3 students per year. Okay. Rates of change in mathematics, we're trying to use equations. We use a rate of change and we call it the slope. Okay, when we have a line of something, we call it a slope. If you think about it, like if you're walking up a hill, it has a certain slope to it, which is just a steepness of a line. So really, all slope is this, the measurement of the steepness of a line. Okay, but slope really is a rate of change. So when you talk about that, it's more like when we graph something, what does the steepness of the line look like? We describe that with something called slope. And again, we've already talked about this really, but we're just going to put better words to it. So slope is equal to how a line rises, okay, how it goes up, or down in some case, so it would be negative, over how it runs. So you guys have all heard that before. Rise over run. Slope is rise over run. Slope is rise over run. You've heard it 1,000 times. Slope is rise over run. So how does something rise over how does it run? Meaning, how does it go up or down versus how does it go left or right? All right. When we're talking about using coordinates from a graph, okay, the rise are the y values because rise are vertical. So we would usually see this as y2 minus y1. Okay, again, we use the second value minus the first value. If you were measuring your height as you grew up and you wanted to see how much you changed, you'd always take the last measurement you have minus however many years back you wanted to go. So it's always the second one minus the first one. Or if you're talking about maybe your bank account, how has it risen? You take your current balance minus whatever your balance was a month ago, and you can see how much it has gone up, or I guess down. Could have gone down. Okay. Run is sideways, so that's our x values. So we go x2 minus x1. So that's rise over run. Is the same thing when we're talking specifically about coordinate values. We say that's y2 minus y1 all over x2 minus x1. Okay, to find an example of that, we can find the slope of a line that goes through a pair of points. Okay, so if we use this first one, let's call this first point. Okay, let's call that our x1, y1, and let's call this our x2, y2. So I'll kind of label that. That's x1, y1, and this is x2, y2. Okay, so we can just substitute these values in then. I know y2 is 5, so slope is y2 minus y1, which is -3, so minus a -3, over x2, x2 is 3, minus x1 is 1. Okay, I know that 5 minus -3 really is 5 plus 3, and 5 plus 3 is 8, and 3 minus 1 is 2, so I've found the slope to be 4. Okay, I want you to try this. Use the coordinate rule for slope, y2 minus y1 over x2 minus x1, to find your slope. Hit pause. Alright, so I'm going to switch this one up on you. You guys probably all called this x1 and y1, and the second point is x2, y2. I'm going to show you that it doesn't matter which ones you call it, first or second, and I'm going to call the first point is point 1, and the second point, or sorry, the first one's point 2 and the second one's point 1. Okay, so if I do that, let's see if I get the same answer you did. Okay, y2 this time I'm going to say is 11. Okay, y1, so y2 minus -9, y1, over x2 -8 minus 24. Okay, so 11 minus a -9, that changes to a plus, so 11 plus 9 is 20, divided by -8 minus 24 is -32. Okay, that simplifies to, let's see, I can divide both of those by 4. So that gives me a negative, because a positive divided by a negative is a negative. Negative 5 over 8. So negative 5/8 is your answer. So you should have gotten the same thing. What probably happened when you flipped the two is that the numerator was negative and the denominator was positive. So you'll see we still get the same answer. If you call, doesn't matter if you pick either point to say that one's 0.1 and the other one's 0.2. That doesn't matter. Okay, last part. We need to find slopes using a graph. Okay, you can use the same thing that you just used where you do the coordinate values, so feel free to do that if you like that better. But there's also something I wanted to show you called a slope triangle. Okay, you have to find 2 points on a graph. Alright, so that looks like a point. It looks like it hits right there at, that would be -8, -2, and then it looks like it hits up here at 8, 4. Okay, to make a slope triangle we go, okay, we're trying to find rise over run, so I go, how far has it gone up over how far has it gone sideways? Okay, well that has gone up 2, 4, 6, so that delta y, or the change in y, the rise, is equal to 6, and the run, it's gone over 2, 4, 6, 8, 10, 12, 14, 16. So my delta x is equal to 16. Well, I know that slope equals the change in y over the change in x, or rise over run. So I know that that is going to be 6 over 16, which simplifies to, I can divide both by 2, so 3 over 8. Okay, just be careful with slope triangles. Remember that the y values have to be going up for delta y to be positive. So if the slope, if we're going left to right and the line goes up, okay, your y value is going to be positive. Then x value, if you always go left to right, should always end up being a positive. So it's really your y value that we determine if the slope is positive or negative, meaning does it go up or does it go down. We got a positive 3/8, meaning this line goes up at a rate of 3/8. Okay, you go ahead and give this one a try. Remember, if the graph is not labeled, which drives me crazy, if the graph is not labeled, assume each of those dashes to be 1. Hit pause. Okay, so if we're doing a slope triangle again, you need to find 2 points, so it looks like it hits right there at that point and right there at that point. So I want to find how much does it rise. Well, this one goes down, okay, and then over. So this delta y, this time, like I said, it's going down, so it's going to be a negative value. So now I go down 1, 2, 3, 4. So that's -4. And it runs over from here to here. That's just 1. So my delta x equals 1. So my slope is equal to rise over run, or delta y over delta x, which is -4 over 1, which equals -4. So this one, it makes sense. We have a negative slope and this line is going down. Okay, bring in any questions you have. Thanks.